Okay, this is lesson 54. We're going to be graphing absolute value inequalities. We're going to be thinking about the concept of absolute value, which is the distance from zero. Okay, so remember yesterday I talked about how far you are away from home. How many ways can you be 2 blocks from home on your street? 2 ways, right? What 2 addresses? If your address is 0, what are the names of the 2 addresses? 2 and -2, right? You're still 2 blocks away from home. So we're using that same idea. So when we have absolute value, we're going to have 2 answers, okay? So just a quick review from Algebra 1, and I showed you this yesterday, but I'm going to just do a quick problem as a review thing. Okay, let's say this was a problem, 3x minus 8, absolute value is equal to 4. Okay, in order to solve this, we know that there's 2 ways to be so far from 0. Okay, so you take this, once the absolute value sign is isolated, you take 3x minus 8, and you just copy it, is equal to 4, and then you take 3x minus 8 is equal to -4. Okay, then you solve each of these, 3x is equal to 12, so x is equal to 4, and then the other one is you're going to add 8 on both sides, so you got 3x is equal to positive 4, so x is equal to 3, or 4/3. Okay. So these are your 2 answers. You're going to have problems like this tonight. Yep.
Do you have to leave these fractions, or can you change them?
You could change them, but you know, once you're going to go up to higher level math, like advanced math or calculus, you do a lot of improper fractions. Okay? Good question. I don't care. It's the same thing. It's just an extra step. So that's how you do that. That's a review. One more thing, one more concept. Absolute value signs always make numbers positive, right? Absolute value signs always make things what?
Positive.
Positive, right? Can I ever have an absolute value sign equal to a negative number?
No.
No. Okay, so sometimes your problems will look like this. Let's say it's the same kind of problem. Absolute value 3x minus 8 is equal to -4. Absolute value signs always make things what, everyone?
Positive.
Positive. So is it possible that this absolute value will be equal to a negative number?
No.
Is that true? Is that logically true?
No.
No, it's not logically true. When you have an absolute value sign equal to a negative, this is no solution. Okay, this is all a quick review. But the concept again is absolute value signs make things positive. And since that's the case, we're asking ourselves how far is a number from 0? There's 2 possible ways it could be from 0, okay? Anyways, that's not the lesson, that's just a quick review. Do you want to take a moment to write that down for tonight? So you have it? Okay, I'll pause the video. So continuing on here, these are the steps for today. If you're on the video, you should pause it. So step 2 looks long and it looks confusing, but step 2 is just, you'll see it's pretty straightforward. Okay. Here we go, numbers 1 and 2, please watch. Okay, when you solve absolute value inequalities, it's just like solving with an equation, but it's an inequality. So there's a couple of steps that you need to take consideration in. So first thing, make sure the absolute value sign is isolated on one side. It is. So when that's the case, you could just take p minus 6, take away the absolute value sign, and you copy it the first time as less than 2. Just copy it, not a big deal. Second time, take p over 6, okay? And instead of it being less than, we're going to flip it and put greater than, okay? Did y'all see that? And instead of positive 2, it's going to be what? Negative 2. Does that make sense, everyone, so far? Then we're just solving, so you multiply by 6 on both sides. On the first one, p is going to be less than 12, okay? On this one, we're going to multiply by 6 on both sides, so p is going to be greater than -12. Here are your 2 answers, okay? Now we're going to graph this on a number line. This is really important, and I'll explain why. Take the first one, p is less than 12, go to the number 12. Draw a circle. It doesn't have equal to, so we're not going to fill it in. And it says it's less than, so I know that my line should be going to the left. I don't know how far left yet, but it's going to be going to the left, okay? Then we go to -12, and it's saying p is greater than -12. It's not equal to, so I'm not going to fill it in. And it's going to the right. So if I know that this one's going right and this one's going left, we're going to meet the 2 together, so we're going to draw a nice line all the way across. as so. Okay. So what is this telling me? Okay, it's saying that any of the solutions between negative 12 to positive 12 are solutions. Okay. So let's pick a number. Let's pick the number 0. Okay. Is 0 a solution? What's 0 divided by 6? No, 0 divided by 6 is 0. Absolute value of 0 is 0 less than 2? Yeah. Does that make sense so far? Let's pick positive 6. What's 6 divided by 6?
1.
What's the absolute value of 1?
1.
Is 1 less than 2?
Yes.
Good. What about negative 6? Negative 6 divided by 6 is?
Negative 1.
Negative 1 is, what's the absolute value of negative 1?
1.
Is 1 less than 2?
Yes.
Yeah, see? Now let's try this. 12. What's 12 divided by 6?
2.
What's the absolute value of 2?
2.
Is 2 less than 2? No, that's not true. That's why it's not filled in. So 12 is not a solution, okay? But it's included as the numbers go up to 12 but do not include 12, okay? So if I pick 11.59, that would be a solution. What about negative 12? Negative 12 divided by 6 is negative 2. Absolute value of 2. Negative 2 is 2. 2 is still less than 2, okay? So this is kind of like logic, right? It has to make sense. It has to have logical sense. All right? Does that make sense so far, number 1? Let me do number 2 now. Number 2 is a little bit harder. Okay, first step, isolate the absolute value sign. It's not isolated, so I'm going to have to divide both sides by 2. Because I have all of this absolute value sign multiplied by the 2 here, so we're going to do the opposite. Inverse operation, so we got 10b minus 7. This whole absolute value sign is less than or equal to 37. Okay? Then we're just like on problem number 1, we take the absolute value, erase it, copy the whole problem without the absolute value sign on the first time. The second time, copy 10b minus 7, and switch the sign from less than to greater than or equal to, and then make it negative 37. Okay, now we're solving just like normal. Over here we're adding 7 to both sides. So 10b is going to be less than or equal to 44. Divides both sides by 10. b is going to be less than or equal to 44 over 10. We know 44 and 10 are both even, so 2 goes into each of these. 4 doesn't go into 10, so I know it's not going to be anything bigger. So I'm going to simplify this. b is going to be less than 22 fifths, okay? You could leave it like that. Improper fraction, totally fine. If you want to make it a mixed number, fine with me too. Okay, next solution. Add 7 to both sides. You have 10b is greater than or equal to negative 30. Divide both sides by 10. b is going to be greater than or equal to negative 3. Okay? Those are your 2 solutions, okay? Now we have to graph the solutions. 22 fifths, would you all agree 22 fifths is like saying 4 and 2 fifths?
Yeah.
Okay? So we go 4 and 2 fifths on my number line. So it's not going to be exactly on 4, but a little bit higher than that. Kind of almost halfway. And we're filling it in this time because it includes that solution. And it says it's less than, so I'm going to, in my mind, I know it's going to go left, okay? But I'm not going to draw an arrow yet. Then we go to negative 3. Draw a circle. This one also is filled in because it includes the equal sign. And this one is saying greater than this number, so this one goes to the right. So since we know that these two go left and right, they're going to meet in the middle. So any solution between negative 3 to 4 and 2 fifths are included. Okay? Does that make sense? Let's just check, just for the sake of knowing we did it correctly. Negative 3. 10 times negative 3 is negative 30. Negative 30 minus 7 is negative 37. Absolute value of negative 37 is 37. 37 times 2 is 74. Is 74 less than or equal to 74? Yeah, so that makes sense. Let's pick a different number. Let's pick 5. 10 times 5 is 50. 50 minus 7 is 40. 43 times 2 is 86. Is 86 less than or equal to 74? No, so therefore 5 is not a solution, and that makes sense, right?
Yeah.
So it's got to make sense. It's got to be logical, okay? And you're going to use this. I mean, if you're a computer programmer, anyone want to do computer programming or software programming, coding? Anyone? Maybe. Okay, so you're going to use logic statements like this. You'll tell your program if the value is less than or equal to this, or you make a algorithm, you're going to use logic like this. You have to think through what are your constraints, okay? Anyways, today's Thursday. Let's have twos start today. Twos are talking to the ones about number 1, and then 1 cell 2 is about number 2. Ready, set, number 3. Okay, so we got n plus 2 is less than or equal to 1. That's the absolute value of that. Okay, so step 1, I'm looking at my steps. As a student, isolate the absolute value signs. Are the absolute value signs isolated, I ask myself. Yes or no, kids? Yep. All right, so we got n plus 2 now. We go to step 2. We're writing down n plus 2 is less than or equal to 1. And then we write it down again. N plus 2 is what? Greater than or equal to what? Negative 1. Right? And we just solve. So we got n is less than or equal to negative 1. N is greater than or equal to, I'm sorry, what am I doing here? Oh yeah, no, that's right. Negative 3. Okay, and then you graph them. Why don't you graph these two on your papers? This one we did together, right? So I'll come around and check your work in a moment. Okay, what would I do, everyone? Okay, so we're going to subtract 5 from both sides, okay? So we should have the absolute value of x minus 8 all greater than or equal to 1, okay? This is just like number 3 now. You can finish this one off by yourself. Okay, so on this one we have, if you work it out, I'll work it out for the sake of anyone on the video, x minus 8 is greater than or equal to 1, and x minus 8 is less than or equal to negative 1, so x is going to be greater than or equal to 9, and x is going to be less than or equal to 7, okay? So on your number line, we're going to circle 9, and it's saying that it's going to be going to it's greater than that. So it's going to be going to the right. And this one is saying that 7 is less than, or it's going to be less than 7. It's going to be going to the left, okay? So that means that the number 8 is not included as a solution, right? What if we put 8 into our solution? What's 8 minus 8?
0.
Okay, good. 0 plus 5 is? 5. Is 5 greater than or equal to 6? Nope. Okay, so that's how that works. Or another one you could do is, let's pick a decimal. 7.5. What's 7.5 minus 8? Negative 0.5. Negative 0.5. Absolute value of that is 0.5. 5 plus 0.5 is 5.5. Is 5.5 greater than or equal to 6? No. Y'all got that? So this is these are the only excluded values are the numbers between 7 and 9, but not including 7 and 9. All right, good. Next one. Now before you start number 5, it looks really simple, but what's a red flag you should be looking at? Negative 29, right? Absolute value signs make everything what? Positive, okay. Be careful before you jump to a conclusion. Well, think about the logic of the statement. An absolute value makes things positive, right? So is it true that the absolute value of the left side is going to be greater than a negative number? Is that true?
Yeah.
Yes. That is true, right?
Yeah.
So we should still think about the problem, but now let's think about what values of n can make it positive, okay? If I work this out, you don't have to work this out, but let's think about it. What if I put a positive number in here? Positive 5, for example. Let's test it. Negative 7 plus 5 times 5 is negative 35. Negative 35 plus 6 is negative 29. Is the absolute value of 29, negative 29, greater than negative 29? Is that true?
Yes.
What's the absolute value of negative 29?
Positive 7.
But is 29 greater than negative 29?
Yes.
Yeah, it's true. Okay, let's pick negative 5. Negative 7 times negative 5 is positive 35. Positive 35 plus 6 is 41. Absolute value of 41 is 41. Is 41 greater than negative 29?
Yeah.
Good. So couldn't I pick any number to put in there and it would still be true?
Yeah.
Y'all get that?
Yeah.
So no matter what I put in for numbers 5, it'll be true. So the answer for number 5 is all real numbers. Okay? No matter what you put in for n, it'll be a true answer. All real numbers. Right? We're not including our imaginary numbers because that's a whole different set of numbers. Okay, and when you graph it, if you look at the bottom, I'll just graph it for you right now. You just take a line, and you could overlap the, or draw it above it, showing that all the real numbers. Now let's look at conceptually on number 6. Absolute values make all numbers what? Positive. Look at the logic of number 6. The absolute value of something will be less than negative 6. This left side has to be what? Positive. Is a positive number ever going to be less than negative 6?
No.
No. It doesn't make sense, right? It's not logically true, right? So is there any possible way that I can make this be a true statement? No. So this one is going to be no solution. Okay? So when you do the problems, make sure you're thinking conceptually. You know, absolute values make things positive. And think logically, okay? That's really important. And again, I'm going to go back to the computer programming. Sometimes people write code and there's a glitch, or there's it doesn't work, right? Because they might have put something that doesn't make sense for the computer. The computer is saying the positive number needs to be less than the negative number. The computer can't think that way, so it stops, it glitches or crashes. Does that make sense? So as a computer programmer, you might have to write code that you have to check your code and make sure it makes sense. And they have like programs that checks your code. But anyways, that's just a side note. All right, that concludes the lesson for today. So turn to your neighbor, discuss these 4 questions.